This video goes over common factoring. So to factor a polynomial means to express it as a product. Factoring is the opposite operation of expanding. So the first type we're going to look at is common factoring, where you're taking out something that's in common between two or more terms. So in my first example here, I'm going to look at my first term. I notice I have a 6 and an a, and I notice that my second term is only 18. In common between those two is 6. So what I'm going to do is I'm going to pull a 6 out in front, and then I'm going to divide my remaining terms by 6. So 6a divided by 6 just leaves me with a, and 18 divided by 6 leaves me with 3. Now I've written my polynomial as a product, 6 times a minus 3, and I can check to make sure that if I expand, I'm going to get the same thing I started with. So if I'm checking, 6 times a gives me 6a, 6 times 3 is going to give me 18. So that means that I factored correctly. The next one, now I'm going to look at my two terms. My first one, I have 6x squared. My second one, I have 9x. So now I've got two things in common. The first is that I can divide both of those numbers by 3. The second is that I can divide both of those numbers by x. So that means that my common factor is 3x, and I'm going to put that in front. Now, what I'm trying to do is what I can multiply by to get back to my original terms. In order to do that, I'm going to divide each of my original terms by my common factor. So 6x squared divided by 3x. Number divided by the number gives me 2. X squared divided by x is going to give me x. Now I'm going to move on to my second term. 9x divided by 3x. Number divided by the number gives me minus 3. X divided by x leaves me with no x. Now I've successfully factored, written my polynomial as a product. Let's try another one that has some more variables. My first term is 12a squared b. My second term is 8ab squared. I'm looking for the biggest number and variable combination that those two terms have in common. I'm going to start with my numbers, 12 and 8. The biggest thing that those two have in common is the number 4. Now I'm going to look at my a's. The biggest a that they have in common is 1, and the biggest b that they have in common is 1b. That means that my common factor is 4ab. Common factor means I can divide it by both terms without getting a decimal. So now I'm going to start dividing my first term by my common factor, which will leave me with 3a, and then my second term by my common factor, which is going to leave me with 2b. Moving on to my next one, I've got 12m squared n cubed and 16m squared n squared. First, looking for my greatest common factor. The greatest number I can divide both of those by, again, is 4. I can take 2 m's out of each term without having any decimals, and I can also take 2 n's out of each term. So now for inside my brackets. I'm going to take my first term, divided by my common factor, leaves me with 3n, and then my second term, divided by my common factor, is going to leave me with 4. That's it. Now we're going to try one with 3 terms. So here I've got 24d squared, 40d, and 56. My greatest common factor is something I can divide each of those terms by without getting a decimal. So in this case, my greatest common factor is 8. Same as in the previous examples, I'm going to divide my first term by my greatest common factor. So I would get 3d squared. Second term by my greatest common factor would be 5d. And third term by my greatest common factor would be 7, which gives me my fully factored example. Here, I've got 7mn minus 8xy. here, I have no factoring possible because I don't have anything in common. Moving on to G, a little bit more complicated. I'm going to look for the greatest number first. So it looks like I can divide each of those numbers by 5 without getting a decimal. I can take 3 m's out of each term without any issues. And I can take 2 n's out, or n squared. Same process as before. I'm going to divide my first term by my greatest common factor, which will leave me with 3. My second term by my greatest common factor, which will leave me with 5, n to the 5. And then finally my last term divided by my greatest common factor, which will give me 6, m, and then a bracket to finish off. My H, example H, I could expand here first. I could also notice that this bracket here is the same in both terms. So what I'm actually going to treat that is as my greatest common factor, and I'm going to write that out in front. Now if I divide my first term by x plus 4, all I'm going to be left over with is 7. If I divide my second term by x plus 4, I'm going to be left over with 5x. I have successfully factored that expression. You could also expand and then look for common factors, but that would be a little bit more tedious. I is another example where I have a binomial that is my greatest common term, and I can pull that out in front as 3y minus 2, leaving me with 6y minus 7 left over. This is going to lead us into our next type of factoring, which is called factoring by grouping. Factoring by grouping requires that the expressions be divided into groups to find a common factor, which can then be divided out. You might have to rearrange an expression first. Okay, so let's take a look. I'm going to divide this first 4 terms into 2 groups. My first 2, I'm going to notice that I can take out 2x squared from both those terms, which means I can rewrite those first 2 terms as x minus 3. Then I'm going to take a look at my second 2 terms, and I'm going to notice that I can take out minus 3 from both of those terms, leaving me with x minus 3. Conveniently, now that I've done that, I have the same bracket in both those terms, which I can then factor one more time, leaving me with x minus 3 times 2x squared minus 3. Let's take a look at another example. I'm going to notice that my first 2 terms have something in common, and they have 4m in common, leaving me with x minus 3. I'm going to notice then that my second 2 terms have a y in common, and so I can factor out here y times 2x minus 3, and this is going to give me a way to double check my first bracket. I should have 2x minus 3 in my first bracket as well, because 8 divided by 4 is equal to 2. Now I'm in the same situation as example A, where I've got 2x minus 3 in both of them, leaving me with 2x minus 3, my common factor, and then 4m plus y as my leftover piece. Let's look at a few more. So here, again, I'm going to notice that I've got something in common in my first 2 and something in common in my second 2. And what I'm going to do here is factor out 2x. That's in common between those first 2, which is going to leave me with 3x plus y. And then in my second one, I'm going to notice that I can factor out minus 5 from each of those terms. So that would leave me with 3x plus y. Again, now I have the same binomial as a result of what I factored out, which I can factor out again as my greatest common factor, leaving me with 3x plus y times 2x minus 5. Example D, break it into 2 groups again. And now I've got something in common between my first 2, 4 c squared, which when I factor that out of my first two terms, I'm going to end up with a minus 3. And then in my second term, I just have an a in common here. When I factor that out, I'm going to be left with a minus 3 as well, leaving me with another common binomial, which I can pull out again as the greatest common factor between those two terms. And then I get 4c squared plus a as my leftover piece. Last two examples here. So again, I'm going to divide this into two groups and notice that my first two terms have a greatest common factor of 5x squared, which gives me x minus 2 when I factor that out. I'm then going to notice that my second two terms have a greatest common factor of 4, which is going to leave me also with x minus 2. Now I have that binomial that's the same in both pieces or both groups. I can factor that out again as my greatest common factor, leaving me with 5x plus 4 as the second bracket, generating my polynomial written as a product, which is the whole goal of factoring. The last one here is something a little bit different. You might notice that if I divide this into two groups, like we've been doing the rest of them, I don't have anything in common in my first two, and I don't have anything in common in my last two. What you might notice is that here I've got ax, and here I've got ay, and then I've got by and bx. So what if I rewrote my polynomial as ax minus ay plus by minus bx? So now I'm going to divide it into two again, and I can factor a out of my first term. And in my second term, I'm going to factor out minus b. That's going to leave me with minus y plus x, which I will rewrite as x minus y. I only factored out the b so that my x minus y was the same as the binomial in my first bracket. Now that I've done that rearranging or that grouping, I can take out x minus y as my common term, and that will leave me with a minus b as my leftover. This is one type of factoring, how to rewrite a polynomial as a product.